and we'll get started in 1 second. Yeah, I see your message, Alex. Yeah, I'm just going to record it right now, right on time.
Thank
So,
you, George.
yeah. So I'll post the recording from this. I'll try to, like, right once it uploads, I'll post it right after class, because you only really have like 2 days if you want to study this. Well, and you should want to at least do the homework. Okay, so conic sections, right? When you cut into a cone that's shaped like this, there are 4 possibilities. And when I say cut into one, it's like thinking about taking a plane and cutting into a conic section. Okay, so I'm going to show you each different case. And what we're going to do is figure out how to take an equation and know which shape it is. Okay, so by slicing a plane, you can make a circle, an ellipse, a parabola, or a hyperbola. So let me show you one by one. And, I think, like, I wouldn't say that you need to sit and try to draw each of these if you're taking notes, but because I'm going to post this, but just have in mind, like, if you see the cut here, right? If you cut a plane through it and it's parallel with the ground or the bottom of the cone, then that's going to create a circle. Okay. So that's our first one. And we'll get into the equations for each one. If you cut on a diagonal like this, right, that's going to create an ellipse. So it looks a little bit like a circle in that part, but really what it's doing is creating an ellipse. And, that's you probably learned some of that in class, but remember, like in science, but planets orbit on an elliptical shape, not a circle, even though, some of that old science stuff looks like a circle. Okay, if you cut in this way, right, and you only get one part of the cone, that's going to create a parabola. Now, we already know how to graph parabolas. I've already made you do that, I feel like, multiple times. So that skill, that I'm not going to make you graph a parabola, because I feel like you already know it. Okay, conic sections, right? So the last one is hyperbola. All right, so that's if you cut straight down, right? You create this shape where you have these opposing parabolas that form what we would call a hyperbola. Okay, so those are the 4 shapes. And then let's look at let's look at how we find what they are algebraically. All right, so GQE just means general quadratic equation. And the reason why it's called general quadratic equation is because this is the equation that all conics are built off of. All right, so ax squared plus b, where a, b, c, d, and e are in the set of real numbers. Okay, so those would be just constants. So those are all going to have a number when you do these equations. 1 second to pull this up. All right, so let's look at what happens. Okay, so if A and B are equal, all right, so really the 2 most important parts for determining what a conic section is, or what type it is the numbers that correspond next to x squared and y squared. So if A is equal to B and neither one is equal to 0, then algebraically you can determine that it's a circle, right? And that makes sense because, like, x squared plus y squared equals 25, right? That really there's a 1 here and a 1 here. A is equal to B, and that's the equation of a circle, and the radius is 5, right? So that's how you know it's a circle. Now, if you get 2 numbers here that are both positive, so A times B, or both negative, right? But when you get this, when you multiply them together, you get a number greater than 0. Oh, and one more thing, and A cannot be equal to B, because if it is, then it's just a circle. Then this forms what's called an ellipse. Okay, so that's the second case. And then if you multiply A times B and you get a number less than 0, and again, they're not equal, then that forms what's called hyperbola. All right, now we'll go over the equations for these three because these three I'm going to ask you to graph. But just keep in mind that you can find it algebraically really easy. Oh, and the last one is if A times B equals 0, meaning that A or B is equal to 0, right? Then that forms a parabola. And that makes sense, right? Because parabolas are formed by quadratic equations. And in order for a quadratic to work, right, you need to either have y squared or x squared. You can't have both, okay? So if that equals 0, then you know it's a parabola. So I think this will be, and this you definitely want to have written down because you want to have this committed to memory so you can do it fast. But I'll show you the process and then I'll let you practice some of it and you'll see that once you kind of know how to do this, it goes pretty fast. All right, so if we need to find this, right, we don't even need to factor the whole thing, but we do need to figure out what A and B are, right? So in order to do that, I got to multiply this out. So 2x plus 2 quantity squared is going to become 4x squared plus 8x plus 4, right? Plus y squared. And then I have everything else that's sitting here, right? Now, in order to simplify this so you get it into general quadratic equation form, you would want to subtract 4x squared from both sides so you get a 0 over here. Okay, so I'm going to go ahead and subtract that. But what happens there is that the x squared cancels out. So what you're left with, and I'm going to write this in order now, is y squared. And then I'm going to look for x. I got 8x minus 3x. So that's going to give me 5x. And then I have plus 4y. And then I have 4 plus 6 gives me 10 equal to 0. Okay, so A is equal to 0, right? And then B is equal to 1. So A times B equals 0. So you know it's a parabola. Okay, so all you're doing here is simplifying so that you can figure out what has x squared or y squared, right? Or what the, what the coefficients are. So this one, right, I multiply this out. I get x squared plus xy plus, well, 6 minus 9 is just negative 3. We can go ahead and combine that already, right? So this is negative 3, whoops, minus 4y plus 3x equals xy, right? So the xy, we're just going to subtract. And since you subtract it from both of these, well, it just goes away, right? And so what you're left with is x squared. And now I'm going to write it in order, plus 3x minus 4y minus 3 equals 0. Right, so now it's in general quadratic. But again, my A now is 1, but B, there is no y squared. So B equals 0. So again, this one would be a parabola. And as you get good at these, like I'm just going to ask you, when I give you the quiz on this on Wednesday, I'll just give you 10 of these and you just need to figure out which one it is. And you're just going to record P for parabola, C for circle. It's almost like, well, it's not multiple choice, but there are 4 answers. So obviously if you, well, actually there's 5 if it's neither, if it's none of them. But you're just going to record your answer. So you'll see that as you begin to do these, you don't necessarily need to figure out every part of the equation. You just need to figure out what's going on with x squared and y squared. Okay, so let's look at this one. This is another good one. And like I said, this time I'm going to go ahead and write the whole thing out. But again, if you want to do this fast, you'll find that you don't necessarily have to write the whole thing out. Okay, so I'm going to add the 22y squared. And really, I'm going to add these as well and bring them over. But let's write it first. So once I do this, right, this cancels out. I'll bring those over as well, but I'm going to get 32x squared plus 32y squared. So I got that 10 plus 22 plus 32x plus 22y brought over from the other side. And then 22 plus 32 would give me 54, right? So in this case, A equals 32, B equals 32, A is equal to B. So that means it's a circle. Oops. So that means it's a circle, right? Okay. Any questions so far? It's pretty easy, right? So this is probably, you know, obviously this is the easier part of the like the little mini unit. I mean, we're doing one class, so it's not really even a unit. But okay, so this one, right? You would have to multiply this out, and because you got to figure out what's going on with x squared. But really, look, like you can. I'll do it first in my head, but then just think about the fact that you don't have to do this whole thing. You can see it in your head, right? X squared is going to be on the left side, right? And then when you add another x squared, you're going to have 2x squared. You're going to have 1y squared. So 2 times 1 is greater than 0. So you know it's an ellipse. Okay. So without even multiplying all this out, I have my answer, right? But I'm going to go ahead and multiply it out also just to show you. And so you would get y squared plus 4y plus 4, right, equals negative x squared. So you would add the x squared to both sides, right? And then when I rewrite this in my like general quadratic equation form, it's going to be 2x squared plus y squared minus 4x plus 4y plus 8 equals 0. Okay, so a is equal to 2, b is equal to 1, a times b equals, or sorry, a times b is greater than 0. And so because of that, I know that this is an ellipse.
Mr. Boyce, so
Yeah.
in the quiz, we only write like the last part, the answer?
Yeah, exactly. Yeah, because I'm going to need to grade it quick anyway, and the graphs will take a little while longer. So when you take the quiz, you're just going to write like C for circle, P for parabola. You just put the, and you'll have like, you know, 1 is E, you know, 2 is H. Yeah, that's all you're going to do. So you'll put E for ellipse. And I'll remind you when you take it too, right? And then you'll put H for hyperbola. And then the one other option will be if it's none of those. You could put not, N for none, or you could put not applicable, NA. So I'll show you that, because really anytime you have anything else, like for example, like if while we're talking about it, right? If you have, like say you had x cubed plus x squared minus 2y squared plus 2y, right? This is not a quadratic, right? So this would be NA because of the x cubed, right? So anything where you don't have just squared and linear, or you know, to the first degree of the variables is not applicable, because that's going to be some other type of equation. Make sense? Okay, so this last one, right? You can look at this and see right away there's no x, right? So a equals 0, b equals 1. So this would be a parabola. Okay. So again, you're exactly right. Just to speed this up, when you do these, you can just put the first initial. Let's look at, we didn't look at hyperbola. So let's say we had something like this. We had, say we had 2x squared plus 4x minus 4y plus 2 equals negative 8y squared, right? So I would bring this over here. No, this would have to be positive, sorry. I want to have a situation where it creates a hyperbola. So if I bring this over, right, I'm going to have 2x squared minus 8y squared, right? So it's going to cancel and be right here. So I would have 2x squared minus 8y squared plus 4x minus 4y plus 2 equals 0. So a is equal to 2, b is equal to -8, and then you have a times b less than 0, which means it's a hyperbola. Okay, so the only tricky thing is if you have to do some algebraic simplifying, right? Any questions so far? All right, so I haven't posted the notes for this yet, but I will like right after class. I'm gonna just make sure I do it right after. That way, if you want to work on it beginning tonight, then you have, you just got to do it before Wednesday, so you make sure you're prepared. So speaking of that, then if you go to, see if Power School is still up. Yay, it is. Okay. So if you go to Unit 2A, I made this part where it's called Conic sections. The chapters are not important to you anymore because you don't have the book. But if you go here, there's a homework. And this one, GQE, is general quadratic equations. It's just a long list of them. So I'm recommending you try 11 through 30. But you can obviously do more of these if you want to practice. Okay, there's a ton of them on here. But I'm recommending you try 11 through 30. And if you look at it, right, like 11, you don't even have to do any simplifying, right? And so don't simplify if you don't need to. Like if you look at this one, right, you see you got this 0.2516. Well, that doesn't really matter because x squared, a is equal to 1, and b is equal to 1, so it's a circle, right? And if you look at number 12, I guess I'm doing the first couple for you. I did some of these ones were the ones we just did. That's why I put 11 through 30. But if you were to multiply this out, right, square root of 6x squared would give you 6x squared, right? So this would be 6x squared minus 6x squared. That goes away. And you're just left with y squared. So because of that, it's 0 times 1, which would be a parabola. Okay? So my recommendation is let's take 10 minutes and practice this skill. And then we'll come back together and I'm going to give you just like you can try, I have 7 problems and just try them out and then I'll go over the answers. Okay? So download this document, the GQE. And then if you want the other one, this is going to be helpful as well. So I'll show you, that's more with the graphing. But this one has 3.2 actually has some ones where you can practice as well. This one has classifying right here. So you can look at these, but these are not all in standard form. So this would be the most helpful part of the other one. Looking here. Okay, and then this one has the answers. So, all right, any questions before we take like basically a 10-minute break / try some of these problems out? Nope. Okay, so we'll just stay in the main room. You can turn off your camera if you want. I'm gonna make a coffee. And then we'll come back at 11:55, okay? And I'll try to get you done a couple minutes early, but I gotta show you how to graph them. Sound good? Okay, I'll see you all in a little bit. A couple minutes early if possible. So, yeah, when you get back, turn on your camera. That way I know you're there, unless unless you're having camera issues, which I know 1 or 2 of you have told me in the past. So, okay, so let's do this. I'm going to give you 7 equations here, and I want you to just try it out, figure out which ones, what type they are, okay? So give me 1 second here to pull that up. Okay, so here they are, right? And let's go over first, right? Just a little recap. All you want to do is for each one, you have 5 options, right? So for your answers, you're just going to, when you answer this on the, when you answer this on the quiz, you're just going to want to write P for parabola, and obviously the number of the problem, right? C for circle, E for ellipse, or H for hyperbola, okay? And then the last one, right? Your last option could be N for none, well, kind of none of the above, or NA, not applicable, okay? So that would always be if you have anything higher than second degree variables, right? If you had x cubed or x to the fourth or y to the fourth, or if you didn't have any squared, right? So obviously one example of not applicable is 4x plus 8y equals 6, right? This is none of them, right? Because there's no x squared or y squared. Okay, so let's take about 4 minutes. I'm going to pause the screen, but try each one of these out, record your answers. And if you notice, you can do a lot of these using our little method, right? Let's actually recap one time. Remember, parabola, a times b equals 0, meaning that a or b is 0. For a circle, a equals b. And for an ellipse, a times b is greater than 0. And hyperbola, a times b less than 0. Okay, so you're looking at what's net your coefficients for x squared and y squared, and then figuring out which one of those. Okay, so I can't have both of those showing at the same time, so I'll pause the screen here, give you about, if you, once you get good at these, you can do this in like 2 minutes almost. Okay, but I'll give us like 4 or 5 minutes, record your answers, and then I'll go over them with you. And maybe do the raised hand when you're done so I can know when we're ready to move on. So maybe 2 more minutes, then we'll go over these. And yeah, go ahead and put the raised hand up when you're either done, or maybe there's a couple that don't make sense. Either way, go ahead and put the raised hand up when you're done. Here we go. Got about half done. I'll give it 1 more minute and then we'll go over this. Okay, so we got almost 75 to 80% of us done. So let me show you, let's go over the answers here. Okay, so remember when you do this for the quiz, you can just record, along with the number, just put an H or E or P or whatever it is, right? So for this one, right, I look and I see that A equals 2, B equals 3. So A times B would be a number greater than 0. So I know that this one is going to be, what's that one? What do we have?
Ellipse.
Ellipse, right? So I'll record, I'll just put it over here, right? So this is an ellipse. Maybe I'll write it here too, just to be helpful for the notes. Okay, so then next one, right? A is equal to 2 and B is equal to -3. And you see how you don't even have to really worry about the rest of this. Obviously, these are all like very similar ones, but you don't really have to worry about the rest of this because once you figure out that, you know that A times B less than 0, so that's a hyperbola. All right, so there's my answer there. And we'll keep working through them. So next, A equals -2, B equals -3. And well, those are both negative, right? So when you multiply them, you still get a number greater than 0. So that's going to say that would be an ellipse. All right. So we record our answer, keep moving along. Well, here, right, you don't have any x, right? There's no x squared. So that means that A is equal to 0. And then B is equal to 3. So A times B would still equal 0, which means it's a parabola. Oops, just writing this out. Hold on 1 second. All right, so we've got answer. If you're 100% so far, you're in good shape. If not, you just know, now you're seeing it so you can learn how to practice it. So A equals -3. Now, because if these were both +3, it would be a circle, right? But even if these are, if one is negative and the other is positive, then we know that A times B would be a number less than 0, it would be a negative number. So that's a hyperbola. Okay, so it's my H. And then here we're going to get, you got to do a little bit of simplifying. Well, not really. You just have to bring the 6x squared over to the other side. So it's -6x squared, right? Because you would cancel this out. Because you do want to make sure that they're on the same side of the equation. So if you do that, you would get A equals -6, B equals 3. So that would be a hyperbola as well. All right, and then last one is, well, when you cancel this out, right? This goes away. So you're left with 3y squared, and that means that it's a parabola because your x squared goes away. So A is equal to 0 and B is equal to 3. That's a parabola. Okay. Any questions about how to do that? How to find them algebraically?
Sir, would it be no answer if both terms are just like x and y?
Yeah, exactly. So like if it was 4x, like 4x minus 6y plus 4 equals 0, right? This one would be none.
Okay, so but if one of them is squared, then
Exactly, right. So once it's like this one is 3y squared, right? As long as it has a non-zero coefficient for x or y, then you know that it's going to be at least one of these cases. Now, the other thing to remember is that if it was 4x cubed minus 6y squared, this is also none, okay? Because it doesn't actually matter whatever else is happening here. Once you have something that's non-quadratic, because kind of what you want to think is that like we're creating a two-dimensional circle, right? Or a two-dimensional ellipse. Once you put a 3 here, now you're thinking about three-dimensional, and that's outside of this. So this would also be none. Okay, so you have here this would be none, and then this would also be none. Or so you can just put N or NA. Okay, so that will come up. There'll be like, you're gonna just get 10 of these questions and you'll just put the answer. You don't have to show your work. But what you do want to keep in mind is that NA, like not applicable, is an option. Okay, so I have to show you how to graph it. I'm going to do one of the three types that we're going to do. We already know how to graph parabolas, so we're not going to worry about that one. Okay, but we don't know how to graph, well, you might know, but I'm going to show you how to do it this way. So let's start with graphing a circle. All right, so I'm going to just do one of each example. They do take a little while because, well, as you'll see, you got to do some algebra to get it into the form. But keep in mind, when we talk about graphing a circle, we're going to have this equation, right? So let's first think about the factored form of a circle is going to be x minus h quantity squared plus y minus k quantity squared equals r squared, right? Which is my radius squared. So this is my center is going to be at h comma k, kind of like in vertex form, but not quite the same. And then r is my radius. So I have to get this equation from this form to this form. Anyone have an idea of how I would do it? Any guesses? How could I factor this?
By completing the squares?
Yeah, who said that? I didn't see who said it.
Me.
So yeah, thank you. Yep, that is perfect. That's exactly what we're going to do. We're going to put the x's together and the y's together, and we're going to complete the square for both x and y. All right, so, and that's the way you're going to do all three of them, okay? So I'll show you one example for hyperbola because it's a little bit different. I'm just going to center it at 0, 0 for any questions, but completing the square of x and y, okay? So first thing I'm going to do is write them together, right? So I'm going to group them together. I'm going to say x squared plus 3x plus some number. And then remember, if I add the number here, I got to subtract the number here. And then I'm going to have y squared plus 4y plus some number minus that same number. And I'm going to go ahead and move the -1 over here, okay? So, or well, the 1 becomes -1 on the other side. All right, so remember, completing the square, this is why I kept getting you guys to do completing the square, because the better you are at it, the easier it does come up quite a bit. Right, so remember, we divide 3 by 2 and then square it, so that's going to be 9/4. So this becomes 9/4, and then if I add that, I got to subtract it on the outside. This one is easier, right? 4 divided by 2 is 2. 2 squared is 4. The more you do this, the better you get at recognizing, you know, what the number needed is to complete the square. Okay, so now we're going to rewrite it in partially factored form. So I'm going to go ahead and I'm going to write my x plus 3/2 square, quantity squared, y plus 2 quantity squared, and then I'm going to have minus 9/4 minus 4 equals -1. Okay, so the last thing to do is just move these numbers over so you can get an idea of what the radius is. So next I'm going to have x plus 3/2 quantity squared, y plus 2 quantity squared, and -1 plus 4 plus 9/4. All right, so this is just 3, which we could write as 12/4 plus 9/4. So that's going to be 21/4. Now remember, that's the radius squared. So 1 second, we're going to compile our information here.
Mr. Boyce, isn't it supposed to be 16/4 instead of 12/4? Since it's
Which one?
4, you put 12/4 instead of
subtract the 1.
16/4.
Oh yeah, sorry. I just compressed this to -1 plus 4 is 3. And then I did 3 is 12/4. You see it? Yeah. No, that's a good thing to call me out on those, because sometimes you're right. Sometimes I'm the one making the mistake there. So in this one though, I just did -1 + 4 is 3, and then 3 is the same as 12/4. Yeah. Okay, so now we got our center is -3/2 and -2. Okay, so now I know that. And then I know my radius is going to be the square root of this. Okay, so one thing to think about with 21/4, you kind of need to know the value of the radius in order to graph it. So just remember that this is slightly, it's like 5 1/4, right? So, so that means if you think about square root of 4 is 2, square root of 5 would be probably, it's not all the way to square root of 9. So I'd say it's about 2.3. Okay. So if you're estimating within a tenth or two, I think that's fine. So I'm going to say this is about 2.3. I think if you put in actually I did put in a calculator last year, and I think I got 2.29 something. So close enough. Okay. Because what we're trying to do now is graph this. So I'm going to use the center, and then I'm going to go outward from the center in all directions. And that will allow me to graph. Whoops. Hold on. I was doing that for hyperbola. So when you graph these, I think you can just kind of concentrate on the quadrant where the conic section lies, or the graph of it. So the circle here is going to be -3/2, -2. So I'm going to go ahead and just concentrate in my third quadrant. So this is y, this is x. And we get -1, -2. I'm going to try to space this out equally so I can draw a good image here. You'll see in a minute why I'm doing that. We'll see if I succeed. Last class, it was pretty sorry looking circle when I drew it. So I'm going to try to do a better job here by using the tool in the program. Okay, so remember, and this just reminds me, since we're going over this, when you're doing graphs, you got to remember to tell me the numbers on the axes. If you don't tell me, that's not a complete graph. So what I was thinking of is when you guys did graphs of e to the x and 4 to the x, things like that, you remember you guys had one where it said place it on one axis. On the test, not everybody, some of you did a great job, and it was very clear which one was which, but you just got to make sure that you're labeling it really accurate. My rule is always you want a random person to be able to step in and look at your graph and be like, oh, that's what they were doing, right? It shouldn't just be me knowing what I'm asking for. So just something to keep in mind. Obviously, that's more of a general rule. But okay, so getting back to this, I'm going to put my center here at -3/2, -2. And then if I'm graphing this without a calculator, I'm just thinking, okay, well, it's going to go up about 2.3, right? It's going to go over about 2.3. So we're going to go, would be right before 1, be we'll see when I go make the circle if I did a good job on this. So this would be -1.5, 3.5, about -3.8, right? And then down here would be down 2 and -2.3. So it'd be about here. Now you can just draw a circle from this. When you're doing it for the test, that's what you'll have to do. I'm going to try to draw a circle outward. Well, that's not circle tool, that's ellipse. Hold on one second. Let's see if this works. See how bad or good my graph was. Well, not great, right? Because I'm not matching all the parts, right? But you get the idea here, right? If I was to draw a circle, so maybe I'll try to draw it since I didn't do a good job. If I was to draw a circle here, you're going to have your, oh, this is going to be a sorry looking circle. It looks like, you guys ever watch Family Guy? It looks like the head of the guy Stewie on Family Guy. It doesn't look exactly like a circle, but I'm not going to deduct points if your circle is not beautiful. What I'm looking for is that you're able to space this out correctly and put the center where it needs to be. Okay, so the center, right, is going to be at -3/2. -2, so you should label that as your center. And then you should also put like the radius right here, that is equal to square root of 21/4. I mean, you can simplify this if you want, but it's not necessary. Okay. So maybe our next shapes will be a little better, but any questions on what I did there? All right, so that's a circle. Let's go on to 2 more and we'll be done. And I'll show you where to practice this. So we're gonna skip parabola since I already showed you that. And also we just don't have enough time to be doing extra stuff like that. So, okay, so let's do an ellipse. All right, now keep in mind, let's look at what the general equation of an ellipse is, different than a circle. So the general equation, or like factored form, is going to look as follows. So we're going to have x minus h quantity squared over a number squared. So that's going to be a squared. And then this is b squared. And it's always equal to 1. Okay, so you have to, well, I'll show you how that works in this example, but you have to get it equal to 1. So remember, h comma k is just my center. And then a is like my horizontal radius, okay? Because a is always going to go with x. And then b is like my vertical radius. Okay, so let's look at how we can get this equation to look like this. All right, so the first thing we're going to do is the same as we did before. We're going to complete the square. So in order to do that, we're going to write everything together, right? And actually, we're going to have to do one more step in this one. So let's actually first write them together, and then we'll talk about that. So I'm going to write my 3x squared minus 12x plus 5y squared plus 30y. And then I'm going to go ahead and write the 42 on the other side, okay? Because that's going to be, eventually we're going to find a way to get that to 1. All right, so if we're going to do this, we got to first divide out. You can't have a number in front of this. So you got to divide out the 3. In order to complete the square, right? We need to divide out that number so that we have a 1 here. So that's what I'm going to do. And then I'm going to subtract whatever that number is. And then here, you want to divide out 5. Okay, so got a number to add here. And this is going to get a little messy for a second, but you'll see it. We're eventually going to get to this form. Okay, so half of 4 is 2. 2 squared is 4. So I'm gonna add 4 here. Now remember, if you add 4, you need to subtract not just 4, 3 times 4. So that's going to be -12. Okay. Half of 6 is 3, squared is 9. I'm going to go ahead and I'm going to multiply 5 times 9. I'm going to subtract 45. Okay, everybody with me so far? Any questions yet? All right. So this is just some, gets a little bit complicated algebraically, but it's all going to work out here in a minute. So all right, so I'm going to write my numbers over there in a minute, but I got 5 x minus 2, y plus 3 squared, right? Minus 12 minus 45 is 57. Okay, so then the final thing I want to do, well, not final thing, but the next thing I want to do is I want to add 57 to both sides. So I get rid of it on this side. So now you're at this stage. You're at 3x minus 2 squared plus 5 y plus 3 squared equals 15. So remember, we need a 1 here, right? So we're going to divide by 15. So if we need a 1 here, we divide by 15. So I'm going to go ahead and do that. I'm going to divide by 15 from all 3 parts. And you'll now see what's going to emerge here is now we have the actual equation of an ellipses. Whoops. There we go. So this is going to be x minus 2 squared. Remember, 3 over 5 is the same as 1/5. And then y plus 3 squared, 5 over 15 is the same as 3. And now we have a 1. Okay, so we're almost to the point where we can graph. You can see these problems are long, so you're just going to do one of each type. And then that'll be what you take when you take the test. You should have plenty of time because I'll give you like an hour, but I don't think it'll take an hour. Okay, so now we got our equation, right? Our center is at 2 comma negative 3. And then our x, like our kind of our horizontal radius. Remember, this is the radius squared, right? So this is going to be square root of 5. And then here, our vertical radius is going to be the square root of 3. All right, so this is about, we already said this is about equal to 2.3 or 2.3 is close enough. And then square root of 3 is about equal to 1.7. Okay, finally at a point where we can graph. So we go ahead and we look and we see the center is 2 comma negative 3. So that's kind of in the 4th quadrant. Not kind of, it is.
Wait, Mr. Boyce,
Yeah.
for the radius, will we be able to use our calculators or do we have to guess?
No, that one you have to not guess, but think about, always use perfect squares around it, right? Square root of 4 is 2. So square root of 5 is just going to be slightly more than 2. And as long as you are within a 1/10 or 2, that's fine with me. You don't have to like memorize all of them.
Okay.
Make sense? Yeah. So you just want to use your knowledge of square root of 9 is 3, right? So if I'm at square root of 8, I'm probably at like 2.8 or 2.9, So, okay. So, all right. So let's go ahead and graph this. And I'm going to try to use the elliptical tool on here. But we'll see if it works. So here's our x-axis. And do we need to, yeah, this is all going to be down in the 4th quadrant for the most part. So 1 second. It's -1, -2. Let's see, does it even go any lower than that? Yeah, we should go down to -5. And then -1 here. Okay, so remember, I know my center is at 2 comma negative 3. So if you're going to draw this by hand, you just need to think about, you're going to go 2.3 in the horizontal direction. So I'm going to go over 1, 2, 2.3 like that. And I'm going to go over 1, 2, 2.3 like that. And then when I go up, my vertical radius is going to be 1.7. So I'm going to go up 1.7 about here, right? And then down, I'm going to go down 1.7. So you can see the shape start to emerge. Let's see if I did a better job drawing this one. And I can use the elliptical tool. I don't know if it'll work. I think they work like this. Yeah. Oh, this one's a little, yeah. So I did a better job here. Okay, so you can see here, right? So now I've drawn my ellipses. Now, obviously, if you're drawing it by hand, you just do your best job to draw something that somewhat resembles an ellipse, okay? And then the final thing is, if you label this well, I'll know that, you put your points up and below like this. But if you label this well, I'll know this is square root of 3. Same thing here. This is square root of 3. And then this is like square root of 5, right? So if you label these well, you don't really have to write this in, but I'm just writing this in so you kind of remember what we're doing here or how we constructed this. Okay, and then you want to put that your center is 2 comma negative 3. All right, so when you do one of these problems, you want to get it into this, oops, You want to get it into the factored form of whatever shape it is. You're only going to have 3 choices. It'll be circle, ellipse, or hyperbola. And then you want to write it out. Okay? Questions about this one? All right. So we're going to do 2 hyperbolas. But I want to do 2 because I want to show you the 2 different possibilities for hyperbola. And I'm going to center the hyperbolas around 0, 0. If we had like another class period to work on this, I would show you some more complicated ones, but we're going to stick with that because otherwise, yeah, it's going to be too much. So let's just go over hyperbola before we go ahead and try to find the graph of this one. Oops. So the equation of a hyperbola is very similar. It's an ellipse, except it has a minus sign. So the equation of a hyperbola is x minus h quantity squared over a squared minus y minus k squared over b squared equals 1. Okay, so this one is actually, there's 2 possibilities. This one is going to be what's called horizontal. It's a horizontal hyperbola. All right, and then if you had the y first, if y is positive, then it's going to be a vertical hyperbola. So hold on one second. Move this down. So the other case is if you have y is first, like this, over b squared minus okay. And so A and B are kind of that same thing, like the horizontal radius, but I'll show you how to graph it because this one requires a little bit more ingenuity to graph. Okay, so let's look at this one. So this one you can tell is a, sorry, just keep labeling. So this one you can tell is horizontal, right? Because x is positive and it's first. So whichever the positive one is in a hyperbola, I recommend writing it first. So now you got to go ahead and figure out, we got to get this equal to 1, right? So we're going to go ahead and we're going to divide this by 49. So we'll divide by 49. And, you know, normally you would have x minus h, y minus k, but this is centered at 0, 0. And I think to make the hyperbolas a little more attainable, we're going to keep it like that. Okay, so at this point you have equals 1. Okay, now these don't factor out to be nice, easy, like, you know, 1/5 or something like that. So if this happens, right, you can bring this down, and I'm going to rewrite it, and then I'll explain what I did. 49/4, okay? So, and then I'm going to do the same thing here. Minus y squared is 49/9 equals 1. Okay, so what I'm really doing is if this is 9y squared and this is 49, I'm just dividing by 9 from the top and bottom. So this is like 9 divided by 9, and then 49 divided by 9, okay? So that works because this cancels out, and this is, you know, this is equivalent to this. So, okay, so we know our center is at 0, 0, okay? And then we also know that our x radius is going to be, I'm calling it that. I'm sure that's not the, maybe there's a term for it. I honestly, I can't remember. Does anyone know? Yeah, I don't remember if there's a term for it, but I just think of it as that. So I take the square root, right? And that's going to be 7/2. And then I take the square root here of 49/9 is going to give me 7/3. Okay, so now I have enough here that I can go ahead and start to graph this. So hold on one second. This part is always like, this one's the trickiest to graph. So I want to make sure I do this right for you guys. So do it over here and try to not make this too large. Okay. So if I go to graph this, right, I know it's centered at 0, 0. So I'm going to go ahead and put the center at 0, 0. But first I need to make 1, 2. So I'm going to go ahead and label my axes. Okay, now just to save time here, I'm not going to write every number here, but if it's centered at 0, 0, right, then I'm going to put a dot for in the x direction. I'm going to go 7/2, which is 3.5, right? So 1, 2, 3, and put a dot right here. Okay, that's actually going to become the vertex of this side of the hyperbola. And then I'm going to put a dot here, 1, 2, 3.5 is going to give me a dot right here. 7/3 is like 2 1/3. So I'm going to go up right here and I'm going to put a dot there. Then I'm going to go down 2 1/3. I'm going to put another one. Okay, so now here becomes the kind of art aspect of doing this. Okay, so what you have to draw now is you need to make a box that goes through all of these dots. Okay, so I'm going to draw a line like this. Draw a line like this. I'm making a rectangular box going through all these points. And again, it doesn't have to be perfect. You just want to do as good of a job as you can. As you notice here, I put this line a little too far, but it's close enough that we're going to get the shape that we're looking for. Now, this is the final thing you do. You draw diagonals through 0, 0 and through these corners, right? And what that's going to do is help you see the line of where you draw your hyperbola. All right, so then I'm going to do the same thing over here. I'm going to go through, get pretty close there. Okay, then my final graph is going to look like this. The actual graph I'll put in blue here is going to be, I'm going to have, these are going to form the vertex, and we're going to graph a sideways parabola along the curve, like with these being like asymptotes, okay? So see what I did? I used all those numbers as my radius to form the box. I draw the diagonals through the center, and then I draw my curve. Okay, and then in terms of labeling, again, like, you know, I was trying to do these examples in not too long to get you out on time, but obviously if you label your axes, then I'll know that and you show this here, then I know you've done it correctly. Okay, so I'm just filling this in so that I don't model it poorly for you. Okay. Questions about this one? All right, I'm going to show you one more of, I'm just going to make up one of when it's vertical, okay? Sounds like someone had a question or maybe not. All right, well, if you do, just let me know. Okay, so last one, let's actually erase this. I think I was going to do an extra one if we had time, but so I want to show you when you have a hyperbola that's vertical, okay? So let's say you have 2y squared minus 4x squared equals 16. All right, so this is going to be centered at 0, 0 again, but I'm going to go ahead and I'm going to divide by 16, okay? And so if I do this, I'm going to get y squared over 8 minus x squared over 4 equals 1, right? So now I have it in the correct form. I have a hyperbola. I have my center at 0, 0. And then I know that I have what would be, here's where you have to be careful, right? Your y radius here, or your, y values is going to be square root of 8, which let's say it's about 2.8, might be 2.9, but like I said, I'm not going to deduct if you don't know the exact to the 10th. So then the x radius is just square root of 4. So that's just equal to 2. Okay, so now I go and do that same thing. So I'm going to do this one more time just because this graph is, or this process of graphing is the most difficult. All right, so I'm going to go ahead and I'm going to center it at 0, 0. And then these, I'm going to have to go up here, 2, 3, 4. And then 1, 2, 3. Okay, so my center, right, I know is at 0, 0. If it was centered somewhere else, you would just count up from there. But for purpose of our class, we're just going to center them at 0, 0. So I'm going to go up 2.8. I'm going to go down 2.8. I'm going to go over 2 in the x direction and over 2 in the negative x direction. Okay, now here's where I draw the box that goes through all of those points. So I'm going to start right here, draw this to about here, go through here, down. Okay, now, because the y comes first, remember, that's what I was talking about, that it's a vertical. So this is a vertical hyperbola because y is positive or it's written first. As long as you put it in this form, you'll know which one is minus because it should go second. Okay, and I forgot to draw my diagonals, so let's do that first. So our diagonals are going to be right here and then right here. Okay, so now I can draw it, but remember, you got to draw it vertically, which means my final answer here is going to be use this as your vertex, and you're going to have a curve going up this way, and then another curve going up in this direction. Okay, and then my final one is going to be here. I'm going to have a curve going this way and down here. All right, and then, again, if you're accurate on your labeling your axes, then you don't have to worry about writing every single part out. Okay, just make sure you're accurate on those, and then I can give you full credit for it. Okay, any questions about what I did there? Okay, so as long as you practice this, you're going to be fine. If you don't practice this at all before Wednesday when we take a quiz on it, yeah, it will not go well. So just make sure that you do the homework. So here's what I recommend doing. I'll show you real quick, and then I'll see if anyone has any questions, and we'll be on our way. I will post this, I'll probably go to the bathroom, and then I'll come back and post all of this so that you have it right away. And you can use the notes and the video as well. But in terms of doing the homework, right, any of these GQEs, the general quadratic equation, you now know how to figure out which one it is, and then you can go ahead and try and graph it. If you want to check your work, keep in mind that you can put stuff into Desmos, and it shows you a graph like this. So if I go to Desmos, you can just put whatever general equation you have. You can either write it as the GQE, or you can write it as the actual one, right? And that's going to give you the shape. So let's say you had x minus 4 squared. Let's do a hyperbola. So this one you have to make a fraction. So you gotta get a little bit. You guys know how to. I'll show you real quick how to do this in Desmos, because I think you can do it in your calculator as well, but I think Desmos works the best. So if you want to create a fraction, you can just do it like that. you just hit the divide button. And so now I have 5. And then let's say if you want to copy something, you can use your Command C and Command V. And so let's say I wanted to make a hyperbola centered at 1 comma 4. And then once I put it equal to 1, you can see it pop up. Okay, so obviously you're not getting the box, but really what this is this is one centered at, you know, at 4 comma 1 is the center right here. And then the hyperbola is built around that. So if we just change this to y squared, you would get one centered at the origin. Okay, so that's a good way to check your work, is like if you draw this, then you can go back and say, like, does that look like what I just drew? Okay, and that works for all of them. In this 3.2, this is a good extra worksheet. So I would do 11 through 30, try to graph them. And then if you go to 3.2, this has some ones where you can write them in, you can, you know, do all the work to get them into factored form. And then this also has some ones where it has the graphs and it has the answers down below. Okay. So this is good practice in terms of like, it shows you kind of everything there. All right. That was kind of a lot, but if it doesn't go well on the quiz, remember you can come back on the optional semester exam and try to redo either standard. Okay. Any questions from me before we go?
Are these only 2 standards?
Yeah, exactly. So the first standard is find which type of conic section it is algebraically, and the second standard is graph a conic section. So obviously the first standard is pretty easy. Second one's harder. But what I'm going to do on the quiz is I'm going to give you 10 equations where you just tell me which type it is. Just put P, E, H, C, depending on which it is, or N for neither or none. And then I'm going to give you 3 graphs. Okay. If you can get 2 of the graphs, you probably get a meeting. If you can get all 3, you get extended. Okay.
And will parabolas also come in a graph, like to go over?
No, I'm not. Yeah, I took it off just because we don't have enough time to get into like horizontal parabolas and all that stuff. So the only 3 graphs will be circles. There'll be 1 circle, 1 ellipse, 1 hyperbola. Okay. And I'll center the hyperbola around the origin. I mean, maybe like 2 comma 0, but that would be the most I would do. It'll be on an axis. Okay. So if you practice this stuff, you'll be fine for the quiz. And then, you know, if you have to, you can go back and make, this is actually notes from last year, but I'll replace it with my notes because this has extra stuff that you're not going to need. Okay. Any other questions before we go?
Yes, Mr. Boyce. I wanted to ask quickly, how do you know if a hyperbola it's vertical or horizontal? Like how do you
Yeah, good question. So let's see, where were we at? Here it is. So the key to knowing if it's vertical is if y is first, right? So y first means it's vertical because that's the positive. Okay, and if x is first, like in this one, you notice that x is first, that's how you know it's horizontal. Okay. All right. Anything else before I let us go? I should let you go because it's 12:45. All right, so we'll have a little time to check in at the beginning since this quiz doesn't take near as long. Obviously, the graphs might take about 10 minutes each, but the questions, those 10 questions, you can probably do in about 10 minutes. So at the beginning of Wednesday, I'll let you know, like if you guys have any questions about how to graph something or how to do something, and then we'll go ahead and take the quiz. Okay? All right. I will let you go. I'll see you all on Wednesday. Unless you have questions beforehand, you know where to reach me. Okay? Have a good rest of the day.
Thank you, sir.
Bye, mister. Thank you.
All right, thank you.
Okay.
All right, Mr. Boyce,
Bye,
thank you.
sir. Thank you.
See you.
Mr. Boyce.
See you. Question,
Hey,
Hector?
Mr. Boyce.
Yeah.
Yes, where are you gonna post the video in
I'm
Google?
gonna post it in the Zoom recordings. Yeah. Do you know where that is, right?
No, is it
Yeah.
in Unified?
Well, the Zoom recordings are always like I shared it with you guys a couple times, but I can share it again. It's in Google Drive. So
Oh,
it's
here, let me Let me look it up and see if
It
I
says
have it.
pre-AP, pre-calc Zoom recordings. You can see I have like every date. Yeah.
Did I miss anything apart from the first half of the class?
Yeah, no, well, the first half was where I explained how to do it algebraically. So you know what I'll do? I'll try to upload it to YouTube and send everyone a link, okay?
What unit is this one, mister?
This is 2A. Uh-huh.
Two.
Conic section.
Okay.
You see it on?
Okay, okay.
Virtual? Yeah,
Yes, I see the Zoom recording. Okay, thank you.
yeah. And I'll put it up there and maybe I'll just do a YouTube recording as well so that you guys can just go to the link. Okay, cool.
Okay. Okay, thank you. Have a great day, sir.
All right, you too. Good job on that test. I saw you're great. You did really well. You did 3.
Thank you.
So, all right. See you
Okay.
later. Bye.
See you.